Hello.
Hey, how's it going?
All right, how you doing?
Good, can't complain.
Good morning, everybody.
Morning.
Hey.
We'll wait a minute or two for folks to call in.
Hey, Michael.
Hey, Bill. Somebody has nice birds around them, it sounds like.
Me? Yeah, I do. I live in a pretty spot. I don't know if I ever showed you the view out my window. You see that? There's a pond out there.
Oh, that's lovely.
Yeah. The swans aren't real. They had to keep the geese away. They're plastic.
So I'm pausing. Rick, it doesn't look like they've joined us yet. Is that right?
So Adrian just texted me that he's finishing a customer call.
Hi, I'm in, Rick. Hi.
Oh yeah, so
Hey,
Sorry.
there you go.
Yeah, hi. Sorry for the delay. I was finishing up a customer call.
No, that's cool. I didn't want to start until you were with us, and I wasn't sure if you were. So it feels like, Rick, have you given them sort of an overview on what Operate First and Open Infra Labs and the NERC and that stuff is?
So I roughly explained what it is, but I mean, it probably can't harm if they get like an extra introduction.
Okay. So a tiny bit of history. About 4 or 5 years ago, there was an idea that a group of professors at universities in Massachusetts in the US came up with to create this thing called the Mass Open Cloud, which was meant to be a place where we could actually do systems research in a cloud that was operating at scale. Clearly not at the scale that an eBay operates at, but at a large enough scale that we could get valuable data for research. And some of that was driven by the realization that a lot of the sorts of systems research that they wanted to be able to do, they could no longer do because there were so many private clouds being offered as public services where you couldn't get some of the underlying data. So that was one of the impetuses. A second impetus was to decrease costs for the research universities in Massachusetts, because there's a high-speed data connection to a data center in a low-cost for electricity part of the state. And there was another piece to it, which was the concept that they wanted to create what we refer to as an open cloud exchange, which was the idea that anybody should be able to offer services in a cloud setting. not just the large incumbents or the people that they do business deals with. So those were sort of it was the bazaar instead of the cathedral model. Over time, we actually succeeded in standing up a cloud and getting lots of users and getting to the point where we were banging up against limits of the hardware that we had available. And it's part of the next phase was sort of recognizing, okay, in order to take this to a place where it can be reproduced in other settings, we needed to do a better job of partnering. And that led to some discussions with the Openstack Foundation, which led to Open Infra Labs with the idea of creating a reproducible cloud that could be stood up by others, so that not only is the initial stand-up easier, but that decisions have been made about things like what should the monitoring look like, so that when you're 6 months out or a year out, you're actually in pretty good shape with the decisions that were made out of the box. At a similar point in time, the 5 research universities I mentioned were Harvard University, Boston University, MIT, Northeastern, and the University of Massachusetts. At about the same time, Harvard University and Boston University decided that it would be a good idea to actually offer a service similar to the MOC, but with research computing levels of support, which in the context of the universities means both a professional team of people whose focus is keeping it running like they do with the HPC clusters, SLAs for levels of service that are standardized, whereas the MOC is a best effort level of service. And perhaps most importantly, the idea of facilitators. So if a researcher who is an English professor and knows very little about computers says, I would like to figure out how many times this word is used in Shakespeare's plays. And I'm incredibly simplifying what I know Augustine and who's on the phone and Justin do. That they'll help them figure out the best way to approach that kind of a problem. And it could be a much more, obviously, most of the time it's a much more complex problem than that. And so these meetings are a step in the direction of trying to come up with the sets of requirements around the Open Infra Labs, with customer 0 or customer 1 being the combination of the Harvard and BU project, which is known as the NERC, or the and so that's hopefully that was an explanation that made sense to somebody who doesn't know what all of these different moving parts are.
Yeah, most definitely. Thank you so much for that. Yeah.
And so last week when we were talking about sort of what should we be doing for the next couple of weeks, Rick said, hey, would it be helpful to talk to some people who actually do OpenStack at really large scale? And we were like, yes, that would be amazing.
Cool. So I guess that's why I'm here. Okay. How do you want to run this? Do you guys have a set of questions that I should address? Do you want me to speak freely? What's the expectation? What's the deliverable here from my side? How can I help? How can I contribute to this discussion?
I'm pausing because there are people who are much more, if you know the chicken and the pig model from Scrum, the chicken is the person who is an observer and cares a lot, and the pigs are the people who are deeply involved. I'm much more of a product manager / chicken sort, and most of the other people on the call are frankly the folks who are going to do the work. So I think it would be helpful to hear from other folks.
While other folks are thinking about it, why don't I start just a little bit with an introduction about myself? So I think that would be helpful for everyone. So hi, I'm Adrian. I'm based in Berlin. I used to be a colleague with Rick here, and now I moved on to work for Microsoft, and I'm doing Azure for them. So I'm onboarding people in their Azure cloud. Before that, when in my time at eBay, I was together with Rick, part of the cloud team, the cloud SRE team. So there we were operating a
100%.
there's some background noise. I think someone has their microphone on. Yeah. So at eBay, I was operating cloud infrastructure for eBay in Europe. And that cloud infrastructure was based on OpenStack. I think we had I don't know if it's fully disclosed, but we had in the thousands of nodes. So we had actually 80,000 cores, CPU cores, physical CPU cores that we were operating for eBay. In my role there, I was tasked to build the infrastructure, so build the OpenStack cloud, maintain it, secure it, make sure our customers, which were other different eBay entities here in Europe, were able to run their workload. They were able to maintain their SLAs towards their customers. So the cloud needed to be available for them. They needed to have enough resources, stuff like that. When Spectre and Meltdown came about, eBay was not one of the companies that had prior knowledge to Spectre Meltdown, and therefore we found out when everyone found out. So me and one colleague of mine from my team, we were tasked to patch that cloud. So we had some interesting problems patching at scale very fast that we needed to solve. So my input here can be about how to build that cloud, what errors we did, what I would do better, the things that we measured in our cloud. I can talk about troubleshooting workloads. I can talk about noisy neighbors and the way we finally fixed it. Hardware, I don't know. You guys, if you guys have questions or suggestions, I can dive into a topic.
Yeah, so I mean, just to start things off, I'm Justin Riley, and I'm on the Harvard side of the New England Research Cloud Project. I'm curious to hear a little bit about your configuration management setup for the cloud, what you guys use there.
Yeah.
What upgrades look like? Did you ever upgrade?
Yeah, very good question. That's a complicated subject, as many. I think I'm going to start all of my answers. Oh, that was really hard, or that's really hard. I don't know if we can find a subject that's not super. Okay, so that has a twofold type of answer. The first answer is, how do you enable your team, your developers? So besides the SRE work, which is to keep things up and running, you have a developer role in the SRE team where you develop features for your cloud. So you want to introduce a new SE Linux type of enforcement. That's an iteration on your infrastructure. So that's your development work. So how we did that? So first of all, to enable us in our developer role, each and every one of us from the team had what we called a dev tenant. And inside of that dev tenant, we try to have a deployable Terraform set. So every service that we had, so compute, MySQL, Glance, you name it, we had it as a Terraform module for us in our developer role to enable features for our cloud. So what we basically did, we provisioned on top of the running cloud, we provisioned Terraform modules, and then we ran Puppet. So basically the code that added features was something in Puppet. So to directly answer your question, we were using Puppet for that. But for the actual cloud, so the second part of the question, we had a setup which was called OpenStack on top of OpenStack, right? So we had a smaller we had a number of racks. I don't know, I don't remember. I think we had 12 racks. That was what we called our undercloud. On our undercloud, we were still running Openstack, but a super slim version of Openstack, not with the full CDN. So a lot less features than the overcloud, where we would spawn API nodes. So if we wanted to have a single API, we had a VM running in that cloud. Okay, to provision that, we used Foreman. So we pixie booted the nodes, and then the nodes would pixie boot using a custom pixie boot configuration, and that would pixie boot into Foreman. And inside of Foreman, you would have available nodes, and those nodes based on, you can write rules. We had rules. So based on the number of CPUs, memory, and whatever, you could automatically pre-provision them to be compute nodes, storage, Seth storage nodes, or any other stuff. So that was part of the thing. So once we had the server racked in, someone would power on the server for us. The server would be connected to out of band, to data networks and whatever. And then it would automatically, so we put a lot of work into have that server, once it was racked, to automatically show up in Foreman. Once in Foreman, based on the rules that we wrote, a role or several roles would be applied to a compute host, for example. So it would be applied the hypervisor role and the Seth connectivity role, whatever, and the software defined, the SDN role. So then it would get provisioned with Puppet and Puppet role. And the last part of the question is, once we wanted to do maintenances, maintenances were again a bit two-folded, where a part of the maintenance would have been to roll out Puppet code, and another part of the maintenance would be probably ran with Ansible. Why Ansible and why all of the tools? So I think we ran through Terraform, Ansible, and Puppet. Ansible was super easy to learn for us, and it was a Swiss Army knife, where we could do basically anything very fast with a not so high slope for a learning curve. So those were kind of the tools we used to add features to the cloud, manage the running cloud, and add new nodes, and then upgrade the cloud. Yes, we did upgrades of the cloud several times. We upgraded from CentOS. No, the first upgrade was to change the operating system from Ubuntu to CentOS. The second one was, or the several ones were, to upgrade CentOS from different versions. And since we're using ZFS, we had to upgrade ZFS. And since we were using Contrails for SDN, we had to upgrade the kernel modules for Contrail accordingly. So those were the upgrade paths. I don't think we ever upgraded or we upgraded just modules of OpenStack. So we had to upgrade Keystone for different reasons. We upgraded Horizon for different reasons, but not a full bang upgrade, because our Contrail needed a certain version of Neutron, worked with a certain version of whatever. So I remember now, some of the components were on Kilo, while certain components were on Okata, for example.
Okay, great, thanks. Yeah, we're also using, or experimenting with O. We're OpenStack on OpenStack, and it sounds like things have, certainly changed. Well, I'm not sure which versions you were using back then, but anyhow, it is interesting though to hear that you never did a full-blown major upgrade, and that's something that I'm curious, how often other folks do that in a production setting where it's not just a dev environment where you can just tear it all down and bring it back up. And especially now with this new, with containers and things, and Triple O, it seems now is also itself running Ansible and Puppet and all of these things. So it seems like things have moved beyond where, what you were working with in the past, but I'm still curious if the same problems, remain in terms of doing a full blown upgrade versus, just a OS upgrade or something here and there.
We're interested in that too.
Hi. So let me just give you a bit of more background. We at the time when I started with eBay, I think it was back in 2015. They were already looking at OpenStack services, like you just mentioned, Triple O, but that didn't really didn't really fix some of the requirements that they had. So we spent a lot of time around tooling. We had also time to spend around tooling to install the cloud and have it as we wanted. Another thing, we had a concept there where we called it a share nothing concept. So basically, and there's research from the now dead company HP Hellion, where they said that virtual machine migration or live migration or whatever you want to call it is not really successful. So tying it all together with our concept of shared nothing, we didn't have shared storage, we didn't have live migration possibilities. So we had the technical possibility, we chose not to implement this. So whenever a hypervisor was dying, it was fully accepted that our tenants just respawn everything on a different hypervisor. Back in the day, like I mentioned, we had OpenStack on OpenStack. So we were not using virtual machines. We were using virtual machines. We were not using containers for that. So now you have Koala, so you can spawn containers. Later on, in a later iteration of our cloud, we started to use Koala and have containers running containers for APIs, and that was one of the reasons why we never upgraded the first installations. It was it took a lot of manpower to upgrade. It's not that we didn't want or we could not, it just took a lot of manpower to upgrade. So then we had the concept of using to move to containers, because that would have made it easier, we thought, to upgrade OpenStack. But because we were really tied to Contrail for our networking, operating Contrail in containers made operating OpenStack in general in containers also cumbersome.
Yeah, it seems like Triple O nowadays has grown a lot from the Kala stuff. So it's.
So, Adrian, I have a question for you about your experience there.
Yeah, sure.
So the way that, at least with OSP 13 and earlier, I don't know for sure more recently, but the way that Triple O sets up networking is it runs everything in the host network namespace so that Neutron can run on the host rather than containerized. And I was wondering if a similar solution would have worked for Contrail.
Yes, let me think about that. I can't remember how I understand the question. I don't remember how we have set it up.
So did you ever have a successful upgrade, or did having Contrail and the containers combined make it difficult or to impossible to do that?
So we had successful upgrades both for Contrail and for OpenStack, because we had so now it comes the interesting part. eBay operates several data centers in Europe. So whenever we upgraded one data center, we asked people to move their workload to different data centers. So basically, instead of declaring a full-blown maintenance window that would probably cause some downtime, the business was still running. So imagine they have quite a lot of money to run their business. So they have this possibility to just move traffic. We had possibilities to move traffic to a different data center. So that being said, we upgraded both Contrail using virtual machines and using containers several times successfully, just because we were forced by the support contract. So whenever I think we were running a 3 dot something version of Contrail that had a lot of bugs, and we were pressed by the support contract to upgrade to a newer version, and then again, that took us. That was a project in itself. So it took, I don't know, 2 or 3 people at least. 6 months to do. So to upgrade Openstack first and Keystone to the correct version, and update Contrail in the end to the required supported version from Juniper. Again,
2 or 3 months.
Sorry?
Did you say 2 or 3 months?
6 months.
6 months. Okay, great.
So that was a project in itself. So preparing that and doing that, it was a project in itself. So that would that would bog down the SRE team. So if you have an SRE team, then you have to have probably people that take care of upgrades. So I don't know what networking are you guys using, but at the scale of what eBay was operating, they try to use VXLAN, they try to use quite a lot of other networking technologies, but only Juniper, having Juniper network equipment, were good enough to operate their cloud. So besides the requirements, and I can go through them for why they chose Juniper network equipment and Contrail, they had physical data centers, so we call them legacy data centers. So OpenStack had that requirement to be able to connect to those legacy data centers. So that was easily achieved with Contrail and Juniper. So that was one of the main reasons why we had that. And having that propelled us into having several issues with upgrades or maintainability of the cloud in general. Yeah, I hope I answered your question.
Yes, thank you.
Just looking at the time, I want to make sure that we leave some time, like 10 or 15 minutes towards the end, to talk about the monitoring specific components. So I just wanted to mention that so that people are thinking about the questions they're going to have around that.
I would just open up, like, what were your guys' biggest monitoring needs? I mean, I would love to just hear what the were.
Yeah. Okay. Let me get into that. Okay. So how monitoring was working? Let me think for a second. So yeah, on the host we had Sensu. So Sensu was running a myriad of Bash scripts and Python scripts. That was the first thing. So Sensu was monitoring 3 processes running. So you want to have Nova Compute up and running. You want to have all of the processes running. So we had that. Sensu monitoring running Bash scripts and Python scripts on the compute host. We had the Sensu server that was triggering alarms into pager duty, And then those alarms into pager duty were what we call them aggregated alarms, right? So when, so I personally, or the SRE team was not really interested when one hypervisor would die, but when 30 hypervisors. So I think, if I remember correctly, our one rack was full of 30 hypervisors. So when a bunch of things would fail, we had those aggregated checks that would fire up a pager duty, and then an SRE, an on-call SRE would get called up. So that was the first monitoring layer. Then we monitored using collected D, and yeah, so we had a lot of collected D. We were gathering a lot of collected D data that we would pipe into Grafana. That would get sent to Grafana for different kind of visualization tasks. So one of the biggest challenges with clouds, as you may know, are noisy neighbors. So that in the end, funny enough, we fixed by not overcommitting that much our cloud. So that was one of the, after Spectre meltdown, at least that was one of the fixes that we applied to the cloud, not overcommitting. So OpenStack, the Red Hat version at least, comes with a CPU overcommit level set to 13, and I think in the end we just had it downgraded to CPU overcommit 1.25 or something like that. So just a little bit of overcommit. But the most interesting part that we monitored with collected D, and this one, this you cannot really divide between VMs on your hypervisor, is the memory bandwidth. So you can divide your network, you can divide your CPU, you can divide your memory, your IOPS, but memory bandwidth you cannot split between the VMs on your hypervisor. So that was one of the interesting things that that took a lot of time for us to understand and start to monitor and plot. So we used the collected D with some Python scripts to monitor the host for specific monitoring things. So we had a query where we were looking for orphan VMs, right? So VMs that were that have been deleted by the tenants, but they were still either running on the hypervisors or they had their disks on the hypervisors for certain reasons. So those would be some of the monitoring things that we did. Of course, we had and we implemented Logstash. So for API, for the APIs, the things that we were looking at were latency. So we had special problems with API latency, at least. So the problem was with Neutron and Contrail again. This is why that was one of the reasons that we upgraded as well. I remember one problem was you would create a security group. The Neutron API would give you an OK security group was created OK, but then in the background, the asynchronous call back to Contrail was not taking place or had problems. So you have to monitor the latency of your APIs. You have to monitor the 200s of your APIs and any kind of anomalies. So regarding your OpenStack APIs, that would be the second level of monitoring that we had set up. Let me think. Give me a.
So while I think about it, is everyone actually clear what Sensu is? Because it was mentioned quite a couple of times.
Yeah.
Right. So okay, cool.
we had our own experiment with Sensu. I won't go down that road, but we're not using it anymore.
Right. Cool. Yeah, I just thought I'd mention it because it's more of a check-based monitoring system closer to what Nagios is doing, rather than something modern and current like Prometheus, where I actually evaluate your metrics.
Yeah, we were actually experimenting with it to replace Nagios, and just hit some. Well, we sort of got interrupted by their big rewrite to go away, and that didn't go so well. And we just were like, Nagios worked really well with 2 VMs versus a whole bunch of hardware they wanted us to buy. So, yeah, we abandoned that.
Yeah, so API availability, host availability, different host checks. Yeah, another thing that was really important for us, because we were, well, eBay was a company that was doing personal identifiable data, PII, personal identifiable, whatever. So we had a lot of customer data. So our security stance was really high. So this was one of the reasons to switch to CentOS on hypervisors. We were forced to enable SE Linux. So a different level of monitoring would be the security monitoring part, where where you monitor your hypervisor's firewall and you monitor your hypervisor security constraints, right? Like in our case, SE Linux. So if you had any SE Linux alerts, you would get an alarm, and then we would treat those alarms quite seriously, because those could be VMs trying to escape, yeah, like compromised VMs trying to escape containment, right? So we would treat that super seriously. And then the point that I want to make here is to monitor your security stance, right? Whatever that would be. Another thing that we were monitoring, obviously, it was the capacity of the cloud itself. So how much you actually have resources, how much you have given out to your customers, and how much your customers is actually using out of their quota. So since we started with quite a higher overcommit rate, then we found out that we probably gave our customers quite a lot of quota, maybe more than we actually will have without overcommit on our cloud. So we started to take a good look at that side of monitoring the cloud. So that was, again, super custom scripts built on our using Collecti, if I remember correctly. Yeah, that was also super important, because at some point we understood that some customers asked for more storage than we actually had on the Seth servers. So we had to expand our Seth clusters. So you have to have an overview of how much you allocate in quota, how much is actually used, and how much your hardware with overcommits and everything is actually capable of.
Actually, I'm very curious about the storage setup and what your strategy with Seth was. I mean, obviously, it seems like maybe at that scale, having a single Seth cluster, did you have more than one? What was the scaling like? It sounds like you used O to deploy Seth as well. I'm curious how that went. Although, now, I think it still does that, but there's other avenues, right, with Ceph Ansible being around and things like that. But just curious about the whole Ceph and storage situation.
So yeah, okay. So we didn't use O for anything in our cloud. So we used our custom based script, like I said, the Pixie Boot to Foreman to Puppet. So we had Puppet roles for it.
I thought you were saying undercloud and overcloud, or maybe that was early days. You guys
those were just terms that we used, but probably we borrowed by mistake. But we have not used O, we just reused the terms, and the tooling behind it was Pixie scripts, Foreman, and Puppet. So we haven't used triple O. Okay, so for the storage setup, we had highly dense flash-based Ceph nodes. So I remember that the last iteration of one of the Ceph nodes was 6 terabytes only flash disks. Only SSDs basically, and then we had the big NVMe disk, and then we would put the journals of the OSDs on the big NVMe, and then the last iteration, I think we switched to BlueStore, so we didn't even have the file system on the OSDs. We just had the journal and the thing. We have not ever used erasure coding. We have not ever used cache tearing, whatever. We just kept it simple. Okay. The Ceph setup. The node itself had 2 interfaces, one facing the customers and one facing so two different cards. So not on the same card, just 2 different cards. So one for data replication in the cluster, and one for talking with our customers, which were hypervisors in that sense. We didn't. So we just use RBD for Ceph. We didn't use Rados gateway or anything. So we just used the block storage thing to connect to hypervisors, and then hypervisors would just mount a Ceph volume, and that was it. So whenever you did OpenStack volume create, that would create an RBD volume, and then you could mount it to your VM via the hypervisor via libvirt, right? So that was one thing. About Ceph, I think we have really taken care of. So CentOS or Red Hat uses what it's called IRQ balancing. There's a service called IRQ rebalance or IRQ balance. So we disabled that service, and then we pinned certain CPU cores to IRQs used by the interfaces, in order not to, because you had a lot of disks on the server, and then you didn't want your network card to flip around CPU cores, right? And then probably then have NUMA nodes, different NUMA nodes. So you have to pin that. It's a performance thing. That was one thing that I remember we did for Seth that was interesting, and the size of the cluster. So to come back to your initial question, yes, it was one big Ceph cluster. We had it separated into so you can have the config map, right? What is it called? Yeah, I think it's called the config map of Ceph, and then you have buckets and
Crush map, yeah.
Crush map, yes. Yes, crush map. Yes, sorry, not config map, crush map. You have the crush map, and then you have the data center, and then you have rooms or zones in the data centers, and then you have racks, and then you have servers. So we created a custom crush map rule that would actually mimic our data center. So we had 3 racks in the data center, 3 full racks, or then 6 racks or whatever. But then we would say, make sure one replica. So we created one replica per zone or per rack. We started with small clusters, and then we expanded. So we started with one cluster that had 3 racks, but then in one rack was one zone, and then we made sure that we had one replica per rack, and then we scaled the Ceph cluster where we had multiple racks per zone, and then we had at least one replica in that zone. Yeah. I can tell you about SSDs. We never had an SSD failure in the 4 years that I was in yeah, never. I wrote the guide how to replace an SSD, and what commands you do in Ceph to delete the OSD and whatever, but I think never, like in my operational experience there, we never had an SSD failure.
Nice.
Yeah. For storage, we had the Swift cluster as well, and Swift was really hard to manage. So for object storage, we had a Swift cluster that I never understood how it actually works with the Swift proxies and the rings there. I think I upgraded once and I expanded that cluster once, but it was really hard for me to understand how it actually works. So
do you know why you guys went with a Swift for object storage rather than using Ceph's own object storage implementation?
So in a previous employer, we have used the Rados gateway and the object storage from Seth. But in eBay, they have decided against it because that would introduce too much dependency on Seth. And secondly, there were people in my team that had a larger experience with Swift. So it was just me and one other colleague that we were dealing with Seth, and there were at least 3 other colleagues that had quite good experience with Swift. So there was just a decision that they said, okay, we'll do Swift. So for that, I remember how it was set up, but I can tell you, at least for me, because I didn't have so much experience with it, it was quite a nightmare to operate and to expand the cluster. I remember I had to do, we had to take care of the rings, and we had to do really cool Git commits not to lose the ring history, and yeah, something terrible that I have never. I didn't have this operational issues with Seth.
Okay.
Yeah.
And I'm just asking because I'm not terribly familiar with Swift yet. Is the reason to use that perhaps just the user, like tying the user to Ceph keys, or not keys, but like their tokens to access the object store? Without that, how does that, or I guess Lars, if you know, like how would you tie OpenStack users to an object, a key to access the object store on the Ceph side if you're just using native Ceph?
So in Ceph, you have key rings, and then key rings have different permissions, and then you have multiple key rings, and then you.
Oh yeah, I get how that works. It's more about like if I'm an OpenStack user that's just wanting to access the object store, right? Wouldn't Swift just give me a very convenient way of like I just go through OpenStack and get a key and access the object store?
Oh, you don't.
I would have to kind of go out of band to talk to it.
We're using Ceph for object storage. We're not using Swift and Kaizen. And as a user, you don't get a Ceph key yourself. You interact strictly through the OpenStack APIs. You get a keystone token, and the Ceph object storage server validates that.
Okay, so it sounds like that there is some linkage there that outside of Swift. So awesome.
Right. So we're not running Swift at all. We're just using Ceph object storage.
That sounds lovely. That's what we're familiar with as well.
Okay. Swift was, at least from my point of view, it was terrible to manage. It operated, so whenever we had just one issue in the 4 years that we operated the clusters, where a Swift proxy node died, and then when it came back, we had a setting where we would mark down for, I don't know, 8 hours a Swift proxy, but if it came back 9 hours after, the data that was in that Swift proxy, we would consider as new, and then that data contained files that have been already deleted or modified, right? So we would kind of duplicate the amount of files that we had in the cluster. So that was one thing that we had, one problem that we had with Swift, and with Ceph we never had operational problems, like never. Yeah, it was just easier to manage.
So let me just cut in here really quick. Adrian, I'm sure you'd probably be down to join again if there's more questions in the future, right?
Yes, yes, I can do that. Yeah.
Because I'm not sure if you looked at the participant list, but also Frederick Bunchik was so nice to join today. Because last time we talked about collecting metrics with Prometheus, Thanos, and then potentially making them available to the public via an HTTP API endpoint. And essentially that is what they're doing for all OpenShift clusters with the telemetry data. So Frederick was so kind to join, and maybe it would be good to not have him join to just listen to OpenStack stories. We allow 10 minutes if no one has objections.
That would be great. I had just noticed that Frederick joined, and I was going to ask if there were things we should do. So thank you, Rick, for doing that.
Are you actually still there,
I mean,
Frederick?
I'm happy.
Okay, cool.
Yeah, I'm here. Yeah. I mean, I'm happy to talk about anything that you're interested in. I wasn't in the last meeting, obviously, so if there's anything particular that came out of that meeting that you would like me to discuss. If not, I can maybe talk a little bit about the telemetry system that we're running for OpenShift. I don't know how much Rick went into detail with that, but essentially the way that it works is that we select a number of high-value metrics that we send from every single OpenShift cluster that allow us to essentially, on a very high level, determine the health of those OpenShift clusters. And we do this for literally thousands of clusters. Yeah, we're running this system in production for roughly a year now. So we've gathered a ton of operational knowledge on this, which has been really awesome. And yeah, essentially this works by we have a Prometheus or a set of Prometheuses within each cluster. And these Prometheuses then we essentially whitelist a couple of those metrics. It's roughly 1,000 time series per cluster. And then we use a mechanism called remote write in Prometheus, which essentially you can think of it as database replication roughly. And therefore kind of in a durable and reliable way replicates this data from each of the clusters to our central telemetry system. And that essentially then allows us to, I don't know, like answer questions like, okay, we've been rolling out this new upgrade across thousands of clusters, right? How well is this upgrade actually doing? Like, should we be rolling this out to our production channel now as well? And so on. So kind of to be able to answer those kinds of questions on a super large scale.
Frederick, I have a question for you.
Yeah.
What's receiving the remote writes from the per cluster Prometheuses? Is that just another higher level Prometheus instance or something else?
So this is a component within the Thanos project.
Okay.
Are you familiar with that project?
I'm familiar with Thanos a little bit.
Okay.
Yeah.
So essentially, we actually, it's been almost a year and a half now since we had originally proposed this new component to Thanos. But essentially, we added a new component to the Thanos system, which used to essentially the query used to call out directly to Prometheus instances,
right,
to essentially get raw data and then perform the query. But obviously, on a scale where you would be talking over the internet and to literally tens of thousands of connections, that doesn't scale, right? So we need to actually push this data into a central location where we can have lower latency access to this raw data. And so that's essentially what we did. We built kind of a Dynamo-style system, it performs roughly Dynamo-style replication within itself, and it's like groups of hash rings that accept the remote write protocol, essentially.
So just to clarify in my head, so normally with a typical Thanos install, it sits as a sidecar next to Prometheus and grabs the raw data periodically and ships that up to the Thanos storage engine. You're using, you're not doing that, and instead you're using the remote write functionality to send it to your storage, the Thanos storage. Is that correct?
That is correct. And at the receiving side, it's essentially then replicating a similar mechanism as what we do with the sidecar, which is essentially it receives, it writes all this data into a local time series database, and then does the exact same mechanism where every 2 hours it flushes this storage to disk and uploads it to object storage, and then all the other components are exactly the same.
Okay, very interesting. Is that available in the current release of Thanos?
Yeah.
Okay, that's awesome.
And it's literally what we're running in production. No modifications, no nothing.
Okay.
We have a thin API wrapper around this for like authentication and stuff like this,
Right.
but there's no magic sauce that we're keeping from the rest of the world.
Okay, very cool. What do you do? How much, I guess, how far back do you keep data? Like for regular queries, how far back do you typically run queries or dashboards or whatever?
So our most common like reporting style queries are not much further than 14 days to a month worth of data. But we do keep data infinitely, and sometimes we run queries literally over the entire time span. Now, obviously, that sometimes takes a long time to finish, but as long as the latency there isn't an issue, it typically ends up working, because you can think of it roughly as a MapReduce style system that happens within the Thanos querier.
Right.
It's just a matter of time until it finishes. But yeah, the most common things are short-term queries, and then we record those, and then we just look at it, the recorded data over time. Right. And that's like,
so how much,
extremely cheap, right?
How much storage do you have dedicated to metrics right now, roughly?
So we have, I would need to look this up, but if I remember correctly, a couple of weeks ago, we looked at this specifically, and I think it's a couple tens of terabytes.
Okay.
And there's one addition to your previous question. There's one other interesting thing in Thanos in regards to time series storage, which is Thanos essentially compacts data every now and then, right?
Right.
And it actually downsamples data as well, so that if you do queries over a really long time period, it actually automatically chooses the resolution appropriate for the time span that you're querying for, which means like if your raw resolution is 5 seconds scrape interval or 15 seconds, kind of a typical 15 seconds or 30 seconds is kind of a typical scrape interval. If you downsample that, the first downsampling period is at 5 minutes, and the next one is at 1 hour, and obviously the difference between 1 hour resolution over a year of data and 15 seconds is enormous, right? So that makes a huge difference, and you're getting literally the same results.
Right, and in Thanos, the downsampling is strictly for query performance. It's not a storage optimization. It's not discarding the second data. It's just generating new data downsampled to the newer time interval, right?
Yeah, so this is somewhat configurable. But we always recommend not throwing away raw data, because essentially the storage cost is not actually all that significantly higher, because when we downsample data, we actually have to store various calculations of that downsampled data, so it doesn't actually turn out to be that much cheaper. Now, if aggressively trying to reduce cost, you can do that. But it's also super nice to be able to look at the year worth of data, and then you see a spike somewhere, right? And you can zoom in. And as you zoom in, you actually get higher resolution data the further you zoom in, right? So we typically recommend to set retention for all resolutions at the same retention period.
Okay. That's all my questions right now. Anybody else?
I wanted to thank both Frederick and Josiah for joining us. I think that Frederick is still with us, but I think the other gentleman had to jump off. We are unfortunately at the end of our hour. I hope this was helpful for folks. I know it was for me.
Yeah, this was very, very useful to listen in and hear these guys' experiences. So thank you.
Yeah, absolutely.
My pleasure.
Cool.
I had a question or a comment. You know, the Openstack Ptg meetings are virtual starting Monday next week, and we could certainly think about scheduling some follow-ups here with you know, more experts and such if folks are interested.
That is certainly something to consider. Yes.
Yeah.
Absolutely.
Cool.
It's Stig here. If you're interested in attending the PTG, the scientific SIG is on Monday at I think it's 1500 UTC from there on, and there should be a number of like-minded operators in that session, which might be a good one to look in on.
Cool. That is the time listed on that same page that lists the other details about that SIG?
Yes, it is.
Cool.
Oh, it's on the PTG pages. I'll see if
cool.
I can add it to the SIG wiki as well.
Cool. Thank you, everybody. I'll be sending some mail around just to make sure that we have a solid target for next week. And also, I apologize, I've been remiss about converting notes from almost 3 weeks ago now into action items. I started doing that again last night and hope to finish it today. And that has some stuff to go into user stories and the like. Cool. Thank you, everybody.
All right.
All right.
Thanks. Great.
Thanks. Bye-bye.
So first.
Thanks.